Good day, everyone. In this video, we will gonna be talking more about Boolean algebra and gate networks. So, the plus and the multiplication operation are physically realized by two types of electronic circuits called the OR and the AND gates. So we shall treat this as black boxes, deferring until later any discussion of how the actual circuitry operates. So a gate is simply an electronic circuit which operates on one or more input signals to produce an output signal. One of the simplest and most frequently used gate is called the OR gate. And the block diagram symbol, as you all know in my previous video, is it looks like this. So the table of combination for the inputs and outputs for the OR gates are this. Since the inputs x and y are signal with values either 0 or 1 at any given time, the output signal z can be described by simply listing all values of x and y of the resulting value for z. So this indicates the OR gate performs in a logical addition on its input because if either of the inputs is 1, then the output is 1. So that is the OR gate. The the AND gate, which is this, the block diagram, performs logical multiplication and input values yielding an output z with value x and y so that z is a 1 only when both x and y's are 1. So just as the plus and the multiplication operation could be extended to several variables using the associative law that we discussed in the previous videos. So, and the next one that we were going to be talking is the complementation and the inverters. The two operation defined so far has been what algebraists would call binary operation. So in Boolean algebra, we have an operation called complementation, and the symbol we shall use is this. It's like a bar. Thus, we write x bar, which means take the complement of x, or another example is x plus y bar, means take the complement of x plus y. So the complement operation can be defined quite simply. So the complement of 0 is equals to 1, and the complement of 1 is equals to 0. So this is the block diagram, and it's called an inverter. So the complement of a value can be taken repeatedly. For instance, we can find x triple bar for x is equals to 0. So 0 triple bar is equals to 1 double bar is equals to 0 bar is equals to 1. And like for example, another example for x is equals to 1, uh, 1 triple bar is equals to 0 double bar is equals to 1 bar is equals to 0. So that is how the complementation works. But yeah, if you think about it, if there is a rule, actually it's a double bar rule. So if you have this, you can just uh, uh, erase this because the answer is always x. For example, 1 double bar. If we take that, if we take this, the double bar of 1, then it becomes 0 bar, so it go back to 1. So you can just take this because it is always equals to the original. So the table of values for the three operations which have been explained are sometimes called truth tables or tables of combination. To study a logical expression, it is very useful to construct a table of values for the variables and then to evaluate the expression for each of the possible combination of variables in turn. So consider this table. I made a table example here. Uh, So in this table, we have a complementation, a logical multiplication, and logical addition. So we have to fill this out. So in this table, we have a z complement. So this means that we have to complement the z. So what is the complement of 0? 1. What is the complement of 1? 0. What is the complement of 0? 1. What is the complement of 1? 0. What is the complement of 0? 1. What is the complement of 1? 0. What is the complement of 0? 1. What is the complement of 1? Which is 0. And in this, we have to multiply the y and the z complement multiplication. So this means that it is only a 1 when both of the inputs here is a 1, because we are doing multiplication. So 0 and 1 means 0, 0 0 is 0, 1 and 1 1, 1 and 0 0, 0 1 0, 0 0 0, 1 and 1 1, and 1 and 0 and 0. And in this, to we have a logical addition here, which means we add this and x. And the rules of logical addition is, if either of the inputs is 1, then 1 is the answer. So x plus y z complement. So 0 0 0 0 0 0 0 1 1, because if either of the inputs is 1, then 1 is the answer. 0 0 0 0 0 0 0 0 1 0 1. Sorry, this is a 1. This is a win. Wait. So this is a 1. X and YZ, then 1. Sorry about that. Uh, then 1 and 0 is 1. 1 and 1 is a 1. And 1 and 0 is a 1. Inputs for the Y, 0 1. So yeah, you can pause the video here if you want to answer this. So uh, in the first problem, we have to complement the x. So the complement of 0 is a 1, the complement of 0 is a 1, and the complement of 1 is a 0, and the complement of 1 is a 0. And the next one is we have to complement the y. So the complement of 0 is 1, complement of 1 is a 0, the complement of 0 is 1, and the complement of 1 is a 0. And the next one, we have to add the x and the y. So we have the logical addition here. So in the rules of logical addition, if is either of the one or both of the one is a 1, then the output is a 1. So 1 and 1 is 1, 1 and 0 is 1, 0 and 1 is 1, and 0 and 0 is 0. And in this, we have to multiply this to the y. Multiply this to the y, and the rules of multiplication or logical multiplication is, if it is only a 1 when two inputs is a 1. Two inputs is a 1. So 1 and 0 is 0, 1 and 1 is a 1, and 0 and 1 is a 0, and 1 and 0 is a 0.